Okay, so today we're going to talk about classifying triangles and then also talk about angles in triangles. Classifying triangles by their angles. An acute triangle has three acute angles. Equiangular triangle has three congruent angles. An obtuse triangle has one obtuse angle, and then notice the other two are going to be acute. In a right triangle, it has one right angle and the other two are also acute, okay? If I name them by their sides, then an equilateral triangle, remember, has three congruent sides. An isosceles triangle has two congruent sides, and then a scalene has no congruent sides, all right? So if we look at our first example right here, it's asking us to classify triangle JMN, triangle JKO, and triangle OLN as acute, obtuse, or right. Okay, so if I use this figure right here, notice that JMN is this big triangle here, okay? This angle right here was said to be obtuse. So since that's obtuse, this would be an obtuse triangle. Okay? JKO is this one right here. Notice that there's a right angle symbol here, which means because this is a straight line, that this is also going to be a right angle right there. So this one's going to be a right triangle. Okay? And then OLN is this one right here in the middle. Notice that this is an equilateral triangle. All three of these angles are actually acute angles, so this would be an acute triangle. Okay? All right, so moving on, if I ask you something like this one right here, it says find the measures of the sides of isosceles triangle KLM with base of KL. So this is our base right here. Remember, isosceles has two congruent sides, so these two would be the congruent sides. They want me to find the measure of the sides. So notice those two, if they're congruent, I'm going to set them equal to each other. 4D minus 13 equals 12 minus D. Okay? So if I add D over, I get 5D minus 13 equals 12. When I add 13, I get 5D is equal to 25. So when I divide by 5D is equal to 5. Okay? So if I'm looking for KL, the base, 5 plus 6 is going to be 11. Remember, these are going to be congruent, so it doesn't really matter which one I put it into. For KM, that would give me 4 times 5, which is 20 minus 13, is going to give me 7. And so far for LM as well, that would give me 12 minus 5, which is also 7. So there's the length for all three of those sides, okay? So remember, I set these two equal to each other because those are the two that are congruent, given that this is the base of the triangle, okay? All right. The next thing that I want to show you is the triangle sum theorem. What it says is the sum of the measures of the interior angles of the triangle is going to equal to 180 degrees, okay? So if I look here at this example, and they want me to find each of the numbered angles, okay? So to find the measure of angle 1, remember, all three of these have to equal 180. Well, 43 plus 74 is going to give me 117. And 180 minus 117 is going to give me 376, 63. Okay? So the measure of angle 1 is 63 degrees. Okay? Keep in mind what you already know about 1 and 2. They are vertical angles, so angle 2 is also going to be 63 degrees as well. Okay, and then to find the measure of angle 3, of course, we could add up 79 plus 63 which is going to give me 142. And when I take 180 and I subtract 142, I get 38. Okay, so the measure of angle 3 is going to be 38 degrees. All right? Okay. So if you wanted to, remember, you could write those as an equation. 43 plus 74 plus the measure of angle 1 equals 180. Okay? For angle 1. And then for angle 3, you could do the same thing. 63 plus 79 plus the measure of angle 3 is equal to 180. Okay? All right, the next thing I want to talk about is exterior angles. Okay? Exterior angles, remember, those are angles that are on the outside of the triangle. They're formed by the extension of one of the sides of the triangle. Okay? They also talk about remote interior angles. So if angle 4 is my exterior angle, then angles 1 and angle 3 would be called remote interior angles. And those would be ones that are the non-adjacent angles. The one that is adjacent is 2. So the ones that are non-adjacent to the exterior angle would be 1 and 3, and those are called remote interior angles. Okay? That leads me to my exterior angle theorem. What it says is that the measure of the exterior angle is equal to the sum of the remote interior angles. Okay? So if I add up these two angles, it should equal the measure of my exterior angle. Okay? Remember, it has to be the ones that are not adjacent. So it can't be the one next to it. It has to be the two that are the remote interior angles, or the non-adjacent angles. Okay? So let's look at one right here. It says find the measure of JKL, which is this angle right here. Okay? Given this figure right here. Okay. So based on our exterior angle theorem, the exterior angle is equal to the sum of the two non-adjacent interior angles, or the remote interior angles. So 7x plus 16 is going to be equal to 5x plus 40. Alright, so if I subtract 5x, I get 2x plus 16 is equal to 40. When I subtract 16, that gives me 2x is equal to 24. And when I divide by 2, I get x is equal to 12. Okay? So if I plug it in right here, that would give me, let's see, 100. So that would give me 100 degrees. So the measure of angle JKL is going to be equal to 100 degrees. All right? Okay, and then the next one is talking about corollaries to the triangle sum theorem. So what it says here is if you have a right triangle, then A and B have to be complementary. Keep in mind that in a triangle, the sum of all three of them is going to be equal to 180. So if you have a right triangle, then one of them is going to be 90 degrees. Then notice all you have left is 90 degrees. So these two, A and B, have to equal 90 degrees. All right? And then the last one says that if L is a right or an obtuse triangle, then JK must be acute angles. All right? So same thing here. Both of these happen to be have to add up to 90, so they both have to be acute if it's a right triangle. And then if L is obtuse, if it's greater than 90, remember, then both of these have to be acute angles.